Yesterday you simplified rational expressions and multiplied and divided rational expressions, and today you are going to add and subtract rational expressions and also simplify complex fractions. When you're adding and subtracting rational expressions, it's similar to adding and subtracting fractions. In order to add or subtract fractions, you have to have a common denominator. Once you have a common denominator, or once you have common denominators, you simply add or subtract the numerators. And that's exactly what you do when you add or subtract rational expressions. So just a reminder here with fractions. You want to find the least common multiple, so the smallest number that they can both go into, and that would be 15. And you want to ask yourself, so once you say, okay, well, I know my common denominator, and you don't have to write this down. I know my common denominator is 15, so I need to change 2/3 to have a denominator of 15. So what would the numerator be? And you can do it that way, or you just can say, what do I multiply 3 by to get 15? And that's 5, so you would have to multiply the numerator by 5. Or if you can't figure out what it is, again, just say 2/3. And you know you need a denominator of 15, you don't know what your numerator is, then you can just the cross product, 3x equals 30, so you know that 2/3 changes into 10/15. And then we want this denominator to be a 15, so we multiply the numerator and the denominator by 3, which is going to give us 9/15. Now my denominators are the same. I add the numerators, but I keep the denominator the same. That's exactly what you do when you add or subtract rational expressions. All right, in section 8.2, you had to identify any values that would make the expression undefined. These are values that make the denominator equal to 0. You're also going to need to identify undefined values in section 8.3. All right, let's start out with adding and subtracting rational expressions with like denominators. That's a very easy process to do. To add or subtract rational expressions, with common denominators, you simply add or subtract the numerators. So let's look at the example that we have here. We have a common denominator of x plus 4. So the denominators are the same, just like up here when we had the denominators the same. We don't change the denominators, we just add the numerators. So denominators are the same. We're going to add x and x to get 2x, and we're going to add -3 and -2 to get -5 or -5. So we have 2x minus 5, and our denominator stays the same. We don't add that, just like we didn't add it up here. And I want to caution you on subtraction, however. If we put a subtraction sign instead of an addition sign between these, you want to put parentheses around that second polynomial because you need to subtract both terms. So this is actually going to end up being x minus x will be 0, and this would be -3 minus a -2. So that would actually turn into a +2. So that's going to be -1 in the numerator, and the denominator will remain x plus 4. Okay, that's if your denominators are the same. Pretty easy to do. Now, we need to, before we can talk about adding or subtracting rational expressions with unlike denominators, we need to talk about finding the least common multiple. We want to find the least common multiple to help us find the denominators. Okay, so to find a common denominator of two polynomials, you must find the least common multiple of the polynomials. And here are some steps that you want to do. You want to, when you're looking for a least common multiple of polynomials, you need to make sure you factor the polynomials. So here, this is factored. This is the same as writing x times x plus 3 times x plus 3. All right, you want to list the different factors. If the polynomials have common factors, you're going to use the highest power of each common factor. All right, so find the least common multiple. Think of multiple, so you want the highest power here. I'm listing all the multiples of 4 and 6, and the least one that they have in common is 12, so that's how you figure out the numbers. Now, it says choose the highest power, So here between x squared and x to the fourth is the highest power. Between y cubed and y to the fifth is the highest power. So highest power here is for x, highest power for y. So our least common multiple for these two polynomials is going to be 12 x to the fourth, y to the fifth. Now, if we have, now these are monomials, so that's how you do the monomials. If you have polynomials, you're going to have to factor. And again, I'm just going to factor these out for you. These are already factored, x minus 3, x plus 1. And this is x minus 6, x plus 1. All right, we need the least common multiple. All right, well, if we look, so basically another way you can think of it is every factor has to be represented. And if there are repeats of factors, then you take the highest power. So we need to have this x minus 3. We need an x plus 1. I'm just reading from left to right. We need an x minus 6. We need an x plus 1. But these are both to the first power. So we really only need it to the first power. So our least common multiple is going to be x minus 3, x plus 1, and x minus 6. So this is how you find a common denominator. Factor, and then you look at all of the factors, and they all have to be represented. If there are duplicates, you choose the highest power. All right, so let's do an example here where we're adding rational expressions. Now, in order to make the denominators the same, you're going to have to multiply the numerator and the denominator by the same polynomial. But just remember, if x plus 2 over x plus 2, that value is 1. So you haven't changed the value of the expression at all. All right, we're going to add and identify any x values. This should be a y here for any x values for which the expression is undefined. All right, so here is our problem. First thing that we need to do is we need to factor the denominator. Now, yesterday you factored the numerator and the denominator when you were multiplying and dividing. Today you're only going to factor that. You're going to start first step, factor the denominator. We're not going to factor the numerator because we have to add or combine like terms in the numerator, just like we did with that fraction right at the beginning. Okay, so we are factoring here, and again I'm going to factor those out for you. It's x minus 3 over x plus 4, x minus 1. And then we have this is just x plus 4. Okay, now I need to look at my denominators. These have to match or I can't add them together. So let's read from left to right. We need an x plus 4 in the denominator. We need an x minus 1. And we need an x plus 4. These are both to the first power. So even though they repeat, the highest power of x plus 4 is 1. So our denominator is going to be x plus 4, x minus 1. So this one's all set. This one, however, we need an x minus 1. So that means I have to multiply this denominator by x minus 1. If I multiply the denominator by x, did I say x minus 1? Anyway, if I said x plus 1, I meant x minus 1. Multiply the numerator and the denominator by x minus 1. Okay, now this one's all set, but this one we have to simplify. So we're going to distribute the 2x through, and that's going to give us our first one. We're just going to rewrite down here, x minus 3 over x plus 4, x minus 1. And then we're going to add that to this distributed. So this is going to be 2x squared minus 2x. Now the reason why I am not factoring these is because I have to add the numerators. Just like this fraction up here, we had to find a common denominator, then we had to add the numerators. Well, if I factor the numerators too, then I'm not going to be able to add them together. So do not factor the numerators when you are adding or subtracting. All right, now we're going to combine like terms. We have a 2x squared. This is going to give us a minus x, and then we have minus 3. Okay. I didn't give myself enough room here to solve the rest of the problem, so I guess we'll just stop here or continue on in just a minute after we talk about the undefined values. So undefined values, x cannot equal negative 4, or that'll make that 0. X cannot equal positive 1, or that will make that part 0. Okay, so adding these together, I just wrote the problem down here. I guess I better move this up. And we have 2x squared And then we have minus x minus 3, and that's over my denominator. Now, this turns into a problem like yesterday. Can I simplify that? Can I make that easier to read? Well, in order to do that, now we're going to factor the numerator. So if I factor the numerator, it ends up being x plus 1 times 2x minus 3, and that's over x plus 4, x minus 1. This isn't going to simplify it anymore, so we can just leave it like this. Now, sometimes you're going to be able to simplify it, and you'll be able to reduce common factors. Okay, so again, a reminder that you're going to, when you're adding, you're going to factor the denominator only. Then you're going to combine the numerators and simplify. And that's if possible. Sometimes you are able to, and sometimes you're not. All right. Now we're going to subtract, and I want you to be very, very careful when you're subtracting, because when you subtract, you have to take the opposite of everything that follows the subtraction sign. So always simplify the sum or difference of rational expressions. All right, now we're going to subtract, and here again, factor the denominator only when you're adding or subtracting until the end when you simplify. All right, so here is our problem, and I'm going to give you the factored form. But before we do that, I'm going to give you the factored denominator is what I should say. This is going to be 2x squared minus 30 over x minus 3, x plus 3. Okay, now we're subtracting, and you want to be really careful because we're subtracting x and we're subtracting 5. So I'm going to write this as minus x plus, or just rewrite it as minus x plus 5 over x plus 3. Now I have to find a common denominator. So I'm going to read from left to right. I know that I need an x minus 3 in my denominator. I also need an x plus 3. And here I have x plus 3 again. Now this one is to the first power, and these are identical, so I take the highest power, and they're both 1. So I don't have to write that one again. Okay, so once I decide what my denominator is, I now have to make these match before I can add them together. This one has an x minus 3, this one has an x plus 3. So looking over here, I have an x plus 3. I'm missing an x minus 3. Yeah, so I need to multiply this denominator by x minus 3, which means I have to multiply the numerator by x minus 3, because this is like multiplying it by 1. So you're not changing the value of the expression at all. Okay, so now that we have our denominators the same, we can just add the numerators, and this will be our denominator. So what I'm doing here is I'm just writing the numerator down again, 2x squared minus 30, minus, and I'm putting this whole thing in parentheses as I FOIL it out because I want to make sure to take the opposite of everything that follows. So I have x squared minus 3x, and then I'm adding 5x and subtracting 15. That goes over my denominator of x minus 3, x plus 3. All right, now I can combine. I have my 2x squared minus 30, and then minus, I combined these two terms here, so plus 2x minus 15. This, when I put parentheses around this, it reminds me to subtract everything. Otherwise, I might think it's minus x squared plus 2x minus 15. Okay, underneath is my denominator, and when I simplify the numerator, I'm going to get 2x squared minus 30, and I just took the parentheses away and took the opposite of the three terms that follow. And then that's going to give me, when I combine these two, it's going to give me an x squared. I don't have any other x to the first power terms, so then it's going to be minus 15. All right, once I have it to this part right here, I have to see if I can simplify it. So that goes back to yesterday's lesson. I'm going to factor the numerator and see if I can reduce it with anything in the denominator. And here, x minus 5, x plus 3 is this polynomial factored, so I can reduce here the x plus 3, and I'm left with the x minus 5 over x minus 3, which is much easier to read than all of this right up here. So that is the simplified. Now I have to go back and identify any undefined values. So my denominator, my original denominator, x minus 3, x plus 3, so x cannot equal 3. X cannot equal negative 3. All right, now the next problem, we're just going to assume that everything is defined. This is a complex fraction, and we want to simplify the numerator and the denominator first because these are two different fractions. So I'm going to pretend this is just the only problem that I have right now. I need a common denominator. This has an x, so we need an x in the denominator. We also need a 2 in the denominator. So my denominator is going to be 2x. I'm comparing this with 2x, and I notice that I have to multiply the numerator and the denominator by 2. So that's going to give me the 6 over 2x. Comparing the 2 to the 2x, which is my denominator, I notice I have to multiply the numerator and the denominator of the second one by x. So that is going to give me x squared over 2x. That's my numerator. Now let's go down here to the denominator. The denominator doesn't have any fractions that have to be simplified or added or subtracted together. Okay, so this basically, it's called a complex fraction. It's a fraction or rational expression divided by another rational expression, which makes it a complex fraction. So just like we did yesterday, we're going to take the reciprocal. Let me write it out like this first so you can see. This now changes to x squared plus 6 over 2x divided by x minus 1 divided by x. So what this means is we're taking this rational expression and we're dividing it by this one. So we can rewrite it like this. We have x squared plus 6 over 2x divided by x minus 1 over x. From yesterday, we learned that if you are dividing rational expressions, you take the reciprocal of the second one and multiply. So that's what we're going to do here. I took the reciprocal, rewrote the first one, took the reciprocal of the second one, and now I can just multiply straight across. So that's going to give me x cubed plus 6x, and in the denominator, I have 2x squared minus 2x. Okay, now back to yesterday. Can I simplify this at all? Let's factor the numerator and factor the denominator. We can pull out an x in the numerator, and we can pull out a 2x in the denominator. So here is x times x plus 6 and 2x times x minus 1. Okay, and it looks like the only thing that we can reduce is the x here and the x here. Now they're multiplied. We're not reducing across any addition or subtraction problems. So we can just reduce here, and we are left with x plus 6 over 2x minus 1. And we said we had to assume that all the denominators are defined, or all values are defined. All right, I just want to quickly remind you that when you're multiplying and dividing, you want to factor the numerator and denominator right away at the beginning. If you're adding and subtracting, you factor the denominator only. You get the common denominator, and then you add the numerator. Then you simplify. If you need to factor the numerator out and reduce it, then you do that.